straight into it. So what I want to say is this is the Food Sense webinar. We like to do this once a month. We do tend to do one in the morning and one in the afternoon UK time, because then we can kind of cover most of the time zone. So I appreciate you guys joining us this afternoon. I'll try and be efficient with the time. So I've kind of got a sort of macro heading here, which is digitization and traceability in the supply chain. So you'll see what I mean by that in a minute. But one way I could express that is the standard way of knowing the hotness of a chili product could be maybe a taste test, or actually you could have gathered some a certificate of analysis by HPLC, but it's not necessarily digitized. You might have received it either as a paper copy or maybe as a PDF, and it needs some sort of translation if you're going to save that data. And the nice thing about the Food Sense that you'll see today is, we do get essentially a digital signal, and it's saved on the cloud and it's traceable later on. But that said, that will come clear as we go ahead. So we are going to talk primarily about the Food Sense Generation 4 this afternoon. Just from the start, actually, I know that most of the people we talk to are very interested in the fact that this technology can measure capsaicin. So therefore, it can measure the Scoville heat units of products like sauces and powders. And I will talk about these kind of samples this afternoon. I will spend a little bit of time talking about heterogeneity. I mean, it's a lovely word, not that easy to say, but heterogeneity for me is just talking about the fact is chilies and chili powders, for example, are actually quite complex samples. They're not evenly, or the capsaicin is not evenly distributed throughout. And it does give some interesting challenges when running things like Scoville heat unit determination on powders, etc. Only a very quick introduction to ZP. I want to be mindful of people having given us the time this afternoon, so I want to be efficient. We were, just so you get a background, we were launched in 2014. We are ISO 13485, so our quality system is, because we make a lot of medical diagnostics, we do contract development and contract manufacturing of medical products. So when you look at Food Sense, you will see that it has quite a lot of similarities to what we call in vitro diagnostics. These are kind of point of care devices. So if somebody's a diabetic and they put a drop of blood on a glucose sensor and you get a result, that's not so dissimilar to what the Food Sense is doing as well. And we're actually using very similar technologies between glucose strips for diabetics and for example, the chili sensor that we're going to demonstrate this afternoon. But I'd also mention that we're going to do chili and ginger this afternoon, but you'll start to become evident as we go through the slides. We do manufacture everything we're talking about this afternoon. When I say manufacture, there's the sensors themselves, there's the hardware themselves, there's doing the quality control on the way out the factory, there's the app, and there's also the cloud system. All this technology is developed by us, so we have full control over it. This is the teams from around the world. So we've got Europeans, US guys, people from Asia. So most of the globe is actually covered at ZP. Just a way in terms of support, I just want to make a quick comment on this. So if somebody's a Food Sense Generation 4 customer, everyone gets personal online training. We just meet online. We have lots of laboratories in the UK and Norway, I should say. And therefore, we provide training from those labs, people with cameras. People can see us in real time doing the testing. And we can also advise them back as well about lab procedure. We do weekly webinars. So if somebody has questions, we can answer those kind of questions pretty quickly in a webinar. And we also have monthly webinars as well. Now, the monthly webinar, what we're doing in the monthly webinars is just demonstrating the hardware and also demonstrating the robustness of this. That I always think that if something's as good as you say it is, then you should be able to sort of turn up and demonstrate it. So we want to do these webinars and we do them live, as you can probably tell. Just to say, if you're interested or colleagues are interested, we are going to have a webinar also on the 25th of January. So we do this monthly. And these webinars are also live demos as well. So it won't all be talk. This afternoon, I should make that comment. It's not all talk. Just to sort of describe the Food Sense a little bit. This is Generation 4. So we literally have had a Generation 0, 1, 2, 3, and now we're on 4, which is a good sign actually, because you do get better every time you kind of you let's say, redo the technology. At this point, it's actually got really quite sophisticated. It is smaller than before. It is definitely easier to use. It's got a lot of really nice mechanical features. It's more accurate. It's also cloud enabled. This cloud enabled is really important because what that means is that I would call the data on this very transparent. So what I mean by that is if you get a certificate of analysis from a third-party analytical house and they say, oh, the Scoville heat unit is 50,000, you have no vision as to, as to what actually happened in order to get that result. You just get the result and you believe it. With this cloud enabledness, we actually get the raw data from the sensor. So you will get a reading on your smartphone. Have no worry about that. It'll just say 15,000 Scoville heat units if it's a sort of slightly hot sauce, 5,000 Scoville heat units if it's a bit milder. If it's a chili powder, it might be 50,000, 100,000 Scoville heat units. You will just get that number, but we'll also be able to back it up with a raw signal as well. But I say is when you actually go and get HPLC done, you have no insight into the raw signal. There's no backing up of it. It's just you believe the reputation of the company that did it. Food sense, we are going to talk about chilies primarily this afternoon, but it is multi-analytes, which means it can do chili at the moment. It can do ginger. We can measure the pungency of ginger, for example. And we can also do total antioxidative status. If something has a lot of antioxidants in it, then it tends to have a longer shelf life. So some of our people are interested in being able to determine the shelf life of materials based on it's called a TAS, total antioxidative status. And you'll see that we can effortlessly move between these different analytes using QR codes, but that will come a little bit more apparent in a minute. This is the hardware. I'm not going to be too long on the hardware because you'll see the hardware for real in a bit. But the hardware's got some nice features. It's got LEDs on it that kind of guide you to tell you that it's powered on. It guide you to tell you that you made Bluetooth connection, tell you that the assay is running, and tell you that the data is uploaded. It's very easy to put the sensors in there. In the past, we had a Generation 3 product. We had to kind of slot this sensor into the front of the box. And then when Solron would be doing a demo, she'd say, oh, you've got to be so careful not to get solution into the slot because it would just suck in there. So we've obviously gone and talked to ourselves and said, guys, what is the problems with this? Listen to people like Solron, who uses the instrument quite a lot, and make sure that we've actually improved it. In that quick video then, you just saw me maybe dismantling the instrument. So it's quite nice. If you want to clean it, we can just pull it apart, give it a wipe down and reassemble it. The other video that's playing here now is just showing a previous demo where we were actually testing the sample, running it through the app, which is what Solon's doing at the moment. The data is collected, the result appears on the smartphone, and the data goes up to the cloud. And then the last little video that's just playing in the background is just showing that we can go from chili to ginger, for example, and we're very interested in what other things that people want to test. I will touch upon that in a bit as well as part of this presentation. What else do people want? So we're very interested to obviously hear about it because then we may be able to add it to the menu as well. So Sense It All, just as FYI, one of the things that has changed with Generation 4 as well is that we've made an Android app. Now, don't worry about scanning this QR code. I might just do it now anyway because I've got my phone here. But what the QR code does, I've just done it. Not that you need to see my screen particularly. What I did is I scanned the QR code because there's an app on the App Store called Sense It All. And that, once you've got that app, when you open it up, the next thing that the app asks you is, it says, it asks you to scan. So if I scan that QR code, which I can do like that, it opens up the Chilli app. If I scan this one, it'll open up the ginger. And if I open up this one, it'll open the TAS. So it's quite nice that this one small unit, but it truly can do multi-analyte. And as I say, we would be kind of super interested to hear what other analytes or tests that people want to do as well. We had one the other day where the people were asking about mustard oil, which I think is something like allyl isocyanocyanate. So we love a bit of chemistry, let's say, at ZP. Something that you will see today as part of this demo, and don't worry, it won't just be talk from me. There will be a real demo, two of them in a bit. What you will see, though, is we have sensors, we have hardware, we have the app. The app is already available on the Play Store. As I say, I'll send you out a video afterwards on this anyway, and you'll get it. We have the cloud, so every time you do a test, the data will end up in the cloud. It's your data, we can't see it. But if you want then us, and I'll show you this, if you want us then to help support on occasions, it's great because we can easily support you because we can actually see the data. So the sensor goes in the meter, the sample goes on the sensor, the app tells the meter, right, this is a chili assay or this is a ginger assay, and it'll run the assay. We get the data back to the phone. You will get a result on your phone. So for example, SHU, Scoville heat units, and then the data will also go to the cloud. Now, one of the things I say here is about speed and certainty. So what I mean by speed and certainty, first of all, it's not hard to run this test, and you'll see that. And it's also quite fast. The whole thing is done in about 2 minutes. And the nice thing about what I mean by certainty is you'll see, I call it like custodianship of the sample. You'll see that Solron will take the source, I think in this case, put it in the buffer, vortex it, put the sample on the sensor, run it, and get the result. That means she completely knows from the beginning to the end all the things that happened along the way, and you get the result. So that gives her certainty that I know what I did, and that's the result. The reason I bring that up is because we do get people who bring us certificates of analysis from analytical labs, and actually you believe the result, but actually you can't really be certain because you weren't in the lab doing that. And one of the things that's with any measurement in the world, there's always an error associated with it. And something that we've noticed is that these errors are never reported. You just get what's an absolute number, right? So that's a lot. I said a lot there, but what we're really good at is actually you will get just the number, but if you were to go into the cloud system, you'd actually see the raw signal as well. So that means there's transparency in this, that when we say it is hot, it's because you can see it, and you'll see it today in this presentation. The signals are big, and when it's mild, they're smaller. So there's a real transparency in actually the result. And the nice thing about it then is that I'm supporting some people in India at the moment. They're users of this, and because they chose to share the data with me, then we can actually look at their data and advise them. So that's a nice feature as well, that you kind of get backed up by a team of sort of PhD scientists as well. I mean, as a side note, I'm not here to labor what's called electrochemistry, but I will mention it very quickly now, and I'll talk about it a little bit more later on. But this C is a very distinctive fingerprint. Just out of interest, this is 2 samples, sample 11, sample 16. This is not my data. This is real data that's come in from India. And we can see the capsaicin. This is literally the molecule, and we can see it. And I can also see that it's in quite high concentration, because these people have a certificate of analysis that says that this thing is like 84,000 Scoville heat units. So they got a document, they believe it. And I'm saying, guys, I don't care what you say, it's hotter. You can see the molecule. We can't make this molecule appear. It's either there or it's not. And how much of there is also out of our control, but it's quite a lot of molecule. So the certificate of analysis that they've got, they're paying for it, but it's actually not accurate because we can see the raw signal. This is something that you'll see in a bit that Solron will do in this today. Sometimes we do chili powder, sometimes we do chilies, sometimes we do chili sauces. I think today it's actually chili puree, and so you'll see Solron do that test in a bit. But you'll also do ginger, and as I say, the reason we bring ginger up is because the more things we can discover that you want to test, then the more of those things we could possibly bring onto the instrument. And suddenly the instrument becomes even more interesting now, because actually it is the same instrument able to do at least these 2, including a third one, which is called TAS. At ZP, I mentioned at the beginning, we're actually what's called ISO 13485. So we actually make a lot of medical sensors. So we've got things like pH and malic acid, and we'd be interested to hear what other people need, because then we may already have it on the menu or in our portfolio, let's say, or we can essentially go away and develop it. So if there's an analyte or an application that you don't hear mentioned today, and it's something that you'd be interested in having added, do let us know. We'd be interested to hear that. The problem that we were originally setting out to solve was that people weren't really, I mean, I've mentioned at the beginning, the slides today, I call them sort of digitization and traceability. So people weren't really doing that much testing when it came to the hotness of chili products. They would do occasional HPLC testing, but it's super expensive and doesn't happen as very often. Panel testing, nobody does this kind of Scoville panel, which is an organoleptic test. You get a bunch of people and they all taste, and when you finish diluting, they can't taste it anymore, then you can score it, but nobody really does it. Guessing, I think happens quite a lot. And then we've got food sense. Problem with HPLC is it is expensive to do. It leads to what we call under testing. So what I mean by under testing is if you've got a large batch of essentially a chili puree or a chili powder or even just chilies, it's very heterogeneous. That means that capsaicin is not evenly distributed throughout. But in fact, when you do HPLC testing, you just take a sample, you send it to the lab, you get one result back. That means you're under testing. It's not really giving you a sense of the capsaicin or the hotness across the entire sample. So it does, and you're under testing because it's basically too expensive. The results can be slow because you have to take the sample, send the sample off to a lab, wait for the results to come back. It's not a fast turnaround. And what you find is actually people have they have certificates of analysis, but they only do it every sort of 3 months or something like that. So it's because it's slow and expensive. And also I'd say that HPLC is a bit of a black box, that people get the certificate of analysis, but because they don't know what's happening in those labs, you just get the number and everyone believes it. But I'll try and peel back what's actually happening. Now the food sense is, depending on depending on the HPLC cost, is a much less cost than the HPLC. And also, if you own an HPLC, it's got a lot of operating costs in terms of organic solvents. The parts in it can be hundreds of dollars for a column, which is, and the organic solvents themselves, you have to dispose of the organic solvents. It's a real pain to have. The food sense doesn't require any of that. It's also a fast, and it's very transparent as well. So I'll get back to that point again about transparency in a short while. So we've got the HPLC, and the HPLC for me is like I say, is a black box. The first problem that you have with HPLC is you have a sample of some sort of chili-based product, and from that you'll sample a smaller amount, and that will go off to the lab. So that means you're only sampling from a much bigger sample. So in fact, you're assuming that the sample you just took was representative of the entire sample. That's an assumption. The first point then the second point that happens is then when it gets to that lab, they do an extraction, but you're not in that lab to see that extraction take place. Then they do a dilution. The reason they do a dilution is because there's so much capsaicin in there. The machine that they're testing upon can't cope with having such a high concentration of capsaicin. So in fact, they have to then dilute it. So they have essentially another step involved. Then they inject it into the machine, which is fairly straightforward. Now, this is it. See, with the food sense, I'm not trying to be too scientific on this, but we can show you the raw data. With the HPLC system, there's what's called a chromatogram. So this is the kind of the signal that comes out and is due to capsaicin, but that's just a signal, because what they then do is they look up against a calibration curve. So they'll have done a calibration at some point. So they take your signal, they look at it against the calibration, and then they calculate from that what the Scoville heat unit rating actually is, and that's when they then put it on certificate and give it to you. Now, the reason I bring that up is because you don't know when they last calibrated that machine. They may have a procedure that says we calibrate every week, but if they calibrate on a Monday and your results are run on a Friday, that machine is definitely drifting. So the thing about HPLC is it is quite a complicated machine. It's quite manual, and when they calibrate it, as soon as the calibration is done, the machine is slowly changing, and the sensitivity is changing. So you don't know when they last calibrated that machine. Now, all that said, the HPLC is obviously expensive. It's not transparent. You don't see what's happening, whereas you will see today that we'll do the entire process in front of you so that you have a good, if you're the one doing it or your technicians in your building are doing it, then you can have a trust in that data. And then the other thing is, if you've got something like 5 steps, which is what they have on the HPLC, you don't know what their error is. Every time you do something in life, there's a little error or a little uncertainty associated with it. Once you stack up all these uncertainties, you can get to actually an uncertainty of something like 25%. I only need to have an uncertainty of 5%, but have 5 steps, and I end up with adding them all up, and I actually have an uncertainty now of 25%. So be super careful, because the thing that we come across the most is people have an HPLC result and a certificate, and it's signed, and it may be even stamped, but that's really not you weren't there in that lab to actually see what was going on. And we find out that actually sometimes these certificates of analysis are not as accurate as you would otherwise believe. So I'll give you an example. If you take a sample and you send it to a lab, you'll get a certificate of analysis. They'll have done it on HPLC, and you'll get a result. Send the same sample to a different lab, you'll get another result, but it won't be the same as the first lab. And if you take the same sample sent to a third lab, you'll get another result, but it will not be the same as the other 2 labs. Now, that's an expensive test to do, so people don't do it. But when it is done, there's no way that they're going to give you 3 exact results. So be careful with those certificates of analysis. This is a test that I have seen people do. They take the same sample, they send it to the lab, they get a result. They then, a month later, send the same sample to the lab and get a result, but it's different from the first result. And then they send the same sample to the same lab again and get a different result again. So be careful, because people do hold these HPLC certificates of analysis as like the gold standard, but nobody's ever really questioning what's actually happening. So this is a classic. So I only use this for really for educational purposes only. But this is exactly what I'm sort of thinking. This is a certificate of analysis that's come from doing the HPLC determination of the pungency of these chilies. So here are the chilies. First of all, these are very heterogeneous. These are dried chilies. Okay, so I know that the capsaicin is actually mostly in the I want to say the placenta on these, or the ovaries rather, is in the ovaries of this chili. So it's not evenly distributed. So I know it's going to be, some error depending on which chili you particularly take or what part of the chili you take. I can see it's HPLC. They're running the AOAC method, so I understand that. This is really intriguing now. They report 11,636, which is quite mild. Scoville heat units, great. But there has to be an uncertainty associated with that number. So is that 11,636 plus or minus 5%, plus or minus 10%, plus or minus 15, plus or minus 20? There has to be an uncertainty associated with that. But they never report the uncertainty. And I get it, because people are basically trusting, and that's fine. But what we are finding is that now that people have access to their own testing, they can actually start to question this a little bit. And one of the things that goes on, like I say, is there's no raw signal. You get a number, but there's a raw signal behind that number. You don't see it. And you certainly don't see when the calibration, how it was done, when it was done, and is the calibration even in date. So be careful of that. The only reason I'm bringing up the University of Oxford now is because today I'm going to talk about transparency. So we'll do a test. So Solron will do a test on some chili samples. She'll get a result, and she'll also go and look at the raw signal as well. And so I just want to bring up that the capsaicin, has something called voltammetry. So I said to you a few minutes ago that what we're doing is actually something equivalent to like a glucose sensor. So what we're doing is running a methodology called voltammetry. Now, this is the voltammetry for capsaicin. This, like I say, this work was originally done in Oxford. When you look at this, I'll let it start from the beginning here. So this, when we run the instrument, what it does is actually does this voltammetry. But our software is really good, because actually it says, if I get a peak like that, that's one indicator that this is capsaicin. And it waits a bit and says, am I going to get the other peak? And then it gets the other peak. Okay, that's 2 peaks that are telling me that this is capsaicin. And then we just wait a few more seconds, and we get another peak. When you look at my raw data later on, you'll see that all the raw data looks like this. That tells us that that's capsaicin. The height of those peaks tells us how much capsaicin is in there. And the fact is, for simplicity, you get the number, let's say 11,000 Scoville heat units on the phone. But we also, if you ever need to troubleshoot it, you can go and look at the data, or you can share it with us and we'll look at the data. But that gives you transparency that what we're saying on that app is actually the truth. And just out of interest, those peaks are not just kind of, let's say the magic as such. Is actually some what's called electrochemistry going on that we're we're electrochemically oxidizing, reducing the capsaicin molecule in order to see that it's, well, to see what it's actually doing. So we know what these peaks mean. They're not just kind of, pretty pictures for us. They're actually a sequence of oxidation and reduction and oxidation events that happen on the electrode. Like I say, my intention's not to lecture on electrochemistry. It's just to give you a sense of why some of the peaks, and that I'll show later on, where they're coming from. They're coming from the voltammetry of capsaicin. So now I'll move forward a little bit faster because I don't want to. If you're interested in chili sauces, that's great. I think one of the hardest things to measure is chilies and chili powders themselves. One of the things we do is we do like to give online training, because capsaicin is not actually terribly soluble in water, for example. It's an organic molecule. It likes to dissolve in fats and oils. So a lot of the training that we do is actually, we know that capsaicin, if you just try to dissolve it in water, it's terribly insoluble, and you can only get it to about a concentration of 500 Scoville heat units. So a lot of the training that we do is to make sure that people are actually testing, not when the capsaicin is still dissolving, but actually when the capsaicin has fully dissolved. So that's one of the kind of things that we like to do in the online training. Make sure you're on this plateau and not make sure that you're not just on this rising curve. But that's part of what we like to do as part of the training. The reason I bring it up is because if we're doing a mild chili sauce, and I know we did this a lot online. So, if we're using Tabasco, it's only 5,000 Scoville heat units, which means we only use a small amount of volume to actually test it. Because we know that if Tabasco has a Scoville heat unit of around about 5,000, if we do a 1 in 10 dilution, we get to 500 Scoville heat units. If we're doing something a bit hotter, so let's say 50,000 Scoville heat units, then we'll do a 1 in 100 dilution, because 50,000 divided by 100 gives us 500. So we kind of have a rule which says, how hot is your sauce or your product? And if it's 0 to 5,000, we say do a 1 in 10 dilution. If you think it's approximately 5 to 50,000, we can do a 1 in 100. And if it's hotter than that, we can do, for example, a 1 in 1,000. But don't worry, because I can see from the raw signal whether you've got the right dilution or not. And that's something that, when you first get going, you can almost say, well, do you think it's right? We can just look at the raw signal and tell you that it's right or not. And if you get stuck, don't worry, we're here to help. And it's easier with our Generation 4 because, as I say, all the data gets saved online. Oh yeah, and so when I say don't worry, what I mean is by that is we can actually look at the raw signal, and I can see there that there's a little peak here. It's between about 5,000 and 10,000. Later on, I'll show you some data where it's actually at 10 rather than down here, and that's because the source is hotter. But we can look at the raw data. We've got a lot of experience. We can just check that everything's okay. This is somebody's data after they got trained by us. They were being very diligent, and must have been quite expensive as well. They've actually tested 15 samples on a HPLC, and they've tested the same samples then on the food sense, and then I should call it error. I should really just call it difference. The difference between the two was actually 5%, 4%, 3%, 3%, 6%, 3%, 5%. When we averaged all those up, we actually end up with a 0% difference, which is nice to have. But as it says, you've got to be a little bit careful with comparing against HPLC, because you've got to assume that the HPLC is actually correct. So you're a little bit careful on that. Just out of interest, I'm just going to talk about heterogeneous samples. Chili powders and a heterogeneous sample. So chilies and chili powders are what we call heterogeneous. I would say Tabasco sauce is something that's much more homogeneous, which just means that it's much more blended up, much more sort of pureed, whereas powders, capsaicin is not evenly distributed through the powder, and it's definitely not evenly distributed through the fruit itself. If you take, and we've done this kind of work, if you take a fruit actually and measure the capsaicin in the different parts, I should say pepper. But if you measure the capsaicin in different parts of it, you actually find out that most of the heatness or hotness, I should say, is actually, or the capsaicin is actually in that ovary section. So that's an extremely heterogeneous sample, because if you took the seeds, you would find there's not much capsaicin actually in them. But if you took the ovary, then you'll find it's there. We are able to follow a process. So, for example, if you take a chili and measure the capsaicin, you might find that it's got a Scoville heat unit in the ovary of about 5,000 Scoville heat units. But once you dry it down, you drive out 90% of the volume, because about 90% of the volume of a chili is actually water. So that means you end up concentrating the capsaicin. We find out then that actually the hotness then goes to about 50,000, which makes sense because we've taken out 90% of the waters. But I always say all that because I just want to say that the chili is a kind of a very heterogeneous sample. This is a little bit of statistics, but if you have a heterogeneous sample and you take a sample, so if I take a sample here, I've missed the capsaicin, so I effectively read 0. If I take a sample here, I've missed the capsaicin, I effectively measure 0. If I take a sample here, I measure capsaicin, I can see a capsaicin molecule, and if I measure here, I can see 2 capsaicins. This is an important point, see, because if the more heterogeneous the sample is, the more tests you have to do in order to really understand that sample. You could just take a sample and take from a very high capsaicin concentration or from a very low capsaicin concentration. If you take something that's more homogeneous, I've broken up the capsaicin a little bit here. Every time we take a sample, we are capturing capsaicin, but we're actually capturing different amounts of capsaicin. But if we take something that's very homogeneous, then when we sample here, we're always capturing capsaicin, and that's much easier to sample. You don't have to take as many samples because the capsaicin is fairly evenly distributed. So extremely heterogeneous would be a chili, more homogeneous would be a chili powder, and something that's quite pureed like a sauce is easier to sample because the capsaicin is more evenly distributed throughout. So just out of interest, if I did some statistics on this, I'd actually find out that I've kind of got this what's called a relative standard deviation of 141%, and that's because that's 0, that's 0, that's 1, and that's 2. If I did the same for this chili powder, I actually have a relative standard deviation of 43%, because that's 1, that's about 3, that's 2, that's 3. But then when you get to Tabasco sauce, it doesn't matter where I sample, we tend to get the same number, and then the relative standard deviation is 13%. This kind of analysis where you take multiple samples on the same sample, or you sample several times from the same powder or the same source, nobody ever does it because it's too expensive to do. But this is really how you'd understand something. And this is a bit of microscopy that I actually did it in the office. So when you look at things like a chili powder, you can see the different colors. It's definitely not a nice homogeneous sample. So sample variability is a thing. So if you really want to understand the hotness of an incoming material, like a chili powder, you would have to actually sample it several times to do several tests in order to actually understand what the Scoville heat unit of that incoming material is. Actually, this is not part of my of the talk today, but I would say that if you can accurately measure the hotness of the incoming material, then you can actually calculate how much of that material to add into something to bring you up to the right hotness. If people are interested, that is something I could cover in another webinar, because I think at the moment people tend to try and make products based on like adding a bit and maybe testing, adding a bit and testing, but actually you can actually calculate that, and it's not something I was going to talk about today, but it just occurred to me. So that said, if you wanted to understand either a product or incoming material, you have to do several samples. Nobody does it because nobody can afford to do it because the HPLC is too expensive, it takes too long. So you'd effectively have to do 5 HPLC runs, which maybe in the US could be $500 depending on what kind of deal you've got. With the food sense, actually, you can do it because you can just do it for yourself quite quickly. So, it's linked to the fact that HPLC is expensive, therefore you're under testing and therefore you get slow results. It's a black box with no sense of error, whereas the food sense is lower cost. You can get a lot more testing done, it's faster results, and it's transparent. When we say what the number is, we can show you the receipts behind where that number actually came from. So a quick case study that we had with a client. In fact, they wanted to know what the hotness of the incoming material was. In this case, again, it's chili powder, which is a hard one. So they sampled it 5 times. So they sample 1, sample 2, sample 3, sample 4, and sample 5. So they took 5 samples, they made 5 solutions, and they tested it on the food sense. And this is the results that they got. 1, 2, 3, 4, 5. So they were able to get the results there and then on their phone. So, they weren't waiting around for the lab or anything like that. They were getting the results, and these are the screenshots that they took at the time. And then they also, I was able to look at that data and say, okay, so I can see it. See, I can see the capsaicin, you know, I can see the peaks, you know, I can see that this is definitely so the only reason I was talking about that Oxford University work earlier on was to sort of say, look, you know, there's a real science behind this, and that's why we know that this is capsaicin and not something else. So they had 5 results, and we were able to actually look at the data. I've got 1, 2, 3, 4, and 5 results. So we were able to see it for each particular one. It's kind of interesting to see because you can see all the peaks and, you know, correlate it against the number and say, yeah, that looks good. You don't have to be doing this work, by the way. You can just look at the numbers. But I just want to say that we do have the receipts behind where those numbers are actually coming from. So what's interesting about a chili powder C is that when they got a sample here, which is 55,000 Scoville heat units. They got a sample here, which was 91,000 Scoville heat units. And then they've got one here at 78, one at 73, and one that's 82. I mean to plot this out, because if I plotted this out, you'd actually find that you've got low, 3 in the middle, and 1 at the end. That's normally distributed. So when you've got something there's an average, but there's some variation on it, you get something called the bell curve. This is basically representing a bell curve. So when they ask what is the hotness of my incoming material, which they know is heterogeneous, the answer is the hotness is actually 76,000 Scoville heat units, or 76,532 Scoville heat units, plus or minus 18%. That's the bit that you don't get from the HPLC. Nobody's telling you that actually, you know, again, you get this number, it's 11,636, but it is plus or minus something, but you don't know because you're not able to afford or do the amount of testing to really tell you what the heterogeneity of that chili powder or that chili sauce actually is. I'll just so the food sense generation 4 is smaller, it's easier to use, it is more accurate, it is cloud enabled, which is great because we can actually support it. It is multi-analyte in terms of you can do chili, ginger, and total antioxidative status, and it is more accurate, and we can back up the accuracy with the back up the accuracy by looking at the raw data. Now at this point, I did promise you some demos, so I will stop talking. I'm going to stop sharing my screen. I'm going to end up turning my camera off and turning my microphone off. And Solron's going to do a quick couple of demos from you. They might be chili and ginger. So Solron, I'll stop and hand over to you. Thanks so much.
Hey, yeah, so my name is Solron and I'm a scientist here at Simmer Peacock, and I'll just lead you through a couple of demos real quick. So we will start with ginger shots, which looks like this, and I will just shake it a bit. So what we need to start by doing is to prepare our sample in order for us to test it. So I will quickly just make a ginger solution consisting of 1 part of the ginger shots and 9 parts of ginger buffer, which gives us a 1 to 10 mixture ratio. So I will add 900 microliters of this buffer, and I will show you like this. So it's see-through, almost looks like water. And then I will add 100 microliter of the ginger buffer. So we vary the mixture ratios that we use, and the mixture ratios depends on the pungency of the solution you're testing. So let's say you were testing a very spicy solution, you would use a higher mixture ratio. And this is in order for us to get to that range where it's most ideal for testing. So here I'll just add the ginger shot into the solution. So you see it mixes fairly well. And then I will just mix it real quick like that. And you see that it's fairly homogeneous, but I will also cheat a bit by using a vortex over here. So now this is good. So next step is to connect the device itself. So I'm showing you, I can show you the app. So let's say the device was disconnected. I will just click the connected device, find my device, and it's all connected via Bluetooth. So, and it's also indicated by a light on the device. I can show you that as well. So I'll just disconnect real quick, and you can see that it's blinking blue, indicating that it's looking for a connection. So now that I connected it, it's a continuous light. So just like that, and then the next thing I will do is I will add I will choose the correct assay. So right now, ginger sensor assay is chosen, which is the correct one, but I will just redo it for the purpose of showing you. So I'll just scan the QR code with the ginger sensor. It was real quick, but what I'm doing is just scanning the QR code. And also I can change the test settings just so that's easier for me to sort through my data later and get all the details. So let's just call this ginger. And I have a cluster named Food Sense Demo in where I will find my results in Chilli. So next thing now is to click on the go to assay. So we have a set dilution factor of 1 to 10. We can vary this, but for this ginger sample, we did mix it 1 to 10. And next step is insert sensor and apply sample to sensor. So the app gives you all the instructions for you to test properly. So I will insert the sensor, and as you can see, it has a cartridge surrounding the sensor, and it's just for the purpose of not touching the sensor and also for spill barriers and so forth. So what I will do now is I will apply the sample to sensor, and I will apply a volume of 50 microliter. 50 microliter is sufficient for covering all the electrodes of the sensor. And I will show you in the camera. Okay, so sorry about that. So here I'll just pipette 50 microliter of the solution we already prepared and onto the sensor, onto the electrodes of the sensor. So be careful not to scratch the electrodes, the surface of the electrodes or anything. Okay, so now that we've deposited that on the sensor, we'll click start measurements. And right now you can see, show you the other screen again. It's a process bar indicating how far along we are. And what it's doing right now, it's running through those cyclic voltammograms that Martin was showing you. He was showing you the ones for capsaicin though, and not for gingerol, which is the one we're looking at in the ginger sample. But it's the same method, but different parameters. So now our result screen is coming up now that it came to a close, and it gives us back the results in micromolarity and milligram per liter, and it also says upload complete, which means that our data has been uploaded to Chilli. And I will take you to Chilli and show you what it looks like. Okay, so just need to sign in and show you those cyclic voltammograms. So the app, so right now you can see our test on the top, which was named Ginger, and you can also see the date and time for our test. So the app is running the cyclic voltammogram, or the device is running the cyclic voltammetry, but it's also analyzing your results. And here you can find the raw data. So the first, very first cyclic voltammogram you can see here is the first scan. So we are running through 2 scans. And here you can see only 1 oxidation and reduction peak. Here are 2 oxidation peaks and 1 reduction peak, which is characteristic for gingerol. And it's in a certain range, which tells us it's gingerol. And it's also, here it shows what range we're looking at to analyze the amount of gingerol in our sample. So, so now I will run through a chili sample. So first off, I will change the assay to chili. So I'm scanning the QR code like that. Now we have chili. I will also change the test ID. So chili, just like that. So that we can differentiate between the two of them easier. But also remember that dates and so forth are also in that sample information. So I need to prepare my sample yet again. And sample preparation, we always have to do that. Right, well, now I will test a chili puree. So what I will do in order for me to easier pipette it, is just to pour some of it into a weighing dish like this. So, and this is a spicy sample. So I will prepare a 1:100 mixture ratio. So, what I will do then, is I'll get a vial like this, and then I have a chili buffer, and I will add 4 milliliters, 4 milliliters and 950 microliters of the chili buffer. So let me show you just this. So into a vial, just like that. And then I will add 50 microliter of our sample, and I'll put it in the close-up camera just for you to see and make sure I'm not cheating. So what you see now is actually real-time prepared samples, just to show you the simplicity. And now I do a lot of talking as well, so some time is wasted on that, but right. Just give me a sec. As you can see, this sample is very chunky, and the more homogeneous you can make the solutions, the better. So just like that. All right, and then I will add it into the solution just like this, and mix it in. And again, I will just cheat a bit, and I will use the vortex just to mix it real well, because right now you can see that everything is falling to the bottom of the vial. And ideally, if it's a very chunky sauce, I will spend more time on the sample preparation and maybe even let it rest on the bench. But just for us to do this quick, this will be fine. So now you can see that it's more homogeneous in the sense that it's distributed around the solution, but you can still see some chunks and bits, and that is okay. The capsaicin is being extracted into the buffer phase. So if you pipette some chunks and bits onto the sensor, that is totally fine. But try to avoid the biggest chunks and bits, of course. Okay, so I will again go to the close-up camera. So these sensors are one-time use sensors, because these organic molecules do like the surface of the sensors quite a lot. So if you would test them over, not dispose them, but retest one, the capsaicin from your last measurement will still be stuck to your surface, and you won't get correct results. So that's why we use new sensors every time. So again, I will pipette 50 microliter of my prepared solution on top of the electrodes of the sensor, just like that. So pipetting it on top of the electrodes, and then I will click go to assay. Well, I will change the dilution factor to 1:200 and click start measurements. And then I will wait for a short minute or 30 seconds, I guess, which is the device running through those 2 cyclical tomograms, in addition to also analyzing the results and calculating just how much capsaicin you got in your sample. So let's give it a few more seconds. And the results are coming back to us in marked molarity, ppm, and scalded heat units. So depending on your preference, you can use different numbers. And it also says upload complete. So again, I will take you quickly to Chilli, just to show you the raw data. Because I do very much like to show you the raw data, because as a scientist, I like to see the data behind my numbers. So I just need to refresh the page real quick. And the raw data can tell you whether you have interferences or what's actually happening with your sample. So you're not just coming in blind and getting a number, which I very much like. So first is the first scan, where you only have 1 oxidation peak. And below you have the second cyclical tomogram, where you see both oxidation peaks for capsaicin, the one similar to the one that Martin showed you in his presentation, and it's analyzing the reduction peak and correlating that to the amount of capsaicin in your sample. So that was a quick introduction to the multi-purpose of our device, and yeah, it's pretty neat.
All right, well, cool. Thanks, Solran. I appreciate that, because obviously I know that we've been talking for something like 50 minutes now, but in that time you had a whole chunk of talk from me, and Solran actually prepared and tested 2 samples in real time, got the results in real time, and got it into the cloud. So so we can actually go back and look at that data later on as well. So I think what I'd like to say, kind of in as we get close to the end here now, is that if you're a Food Sense Generation 4 customer, it is actually really easy to support you, because you can get the result. If you're ever wondering, are we sure about the result? Are we worried about interferences? We can go and look at the raw signal. If you're currently, if there's a test that's currently not on the platform, we would really like to hear about it. So I think in summary, I think I'd like to say, be super careful about HPLC testing. You really don't have a sense of kind of what the when you've got complex samples, and chilies and chili peppers and chili sauces are inherently complex. Just taking one sample, going to the lab and getting a result back that you were never really part of is a little bit it's not necessarily as accurate as you were otherwise thinking. As you can see, Solran said it, actually she's got full custodianship over that process there. She was able to prepare the sample, run the test, and even check the raw data if she was so inclined, but she could have just relied on the Scoville heat unit. And then lastly, as I say, if you're ever in any doubt and you want somebody like ZP to take a look at the data, you can then choose to share it with us, and we can see it as well and just kind of confirm it. So I think we're getting to the end now of our webinar. So I hope we've given you a nice introduction to the technology, to the interesting background in determining Scoville heat units. You actually saw the Food Sense do both a chili and a ginger today. We appreciate that probably most of you are interested in chili, but if there are other analytes or other molecules or other things that need measuring, we'd be interested in hear about it. Because you've attended the webinar today, I'll definitely send you a recording. Once we've processed this, we'll send you a recording, and you can watch it essentially at your leisure. So I want to say a special thank you to Solran. It's getting late where she is. Special thank you to Aftab, who's come in from India this afternoon, or this evening rather, to watch this. And thank you especially to our guests for coming to see the webinar. If you've got any questions, don't hesitate to reach out to us, but also know there'll be an email coming from me shortly anyway, and you'll be able to use that to ask any more further questions. Okay, I want to say thank you and have a good rest of the day. Thanks, Solran. Thanks, Aftab, and thank you, guests. Take care. Bye-bye.